Hello there. Ever since I started this channel, one of the things I've struggled with is how to measure battery drain, and to what extent do I need to measure that. And I've actually gone through quite a bit of evolution since the channel began, and I actually expect I'll continue to evolve in my thinking around this. But I wanted to put together a video that not only kind of shared how I currently thought of battery drain, but looked at that not just specific to a particular device, which is how I've talked about this issue thus far, but starting to compare between devices. This is actually something viewers have mentioned, particularly with my latest review, where I talked about the Nomad and its battery drain. And I think that quite rightly, people commented, well, how does this actually compare to other devices? And how should we feel about some of these numbers that I was showing? And it makes a lot of sense. Context is everything. So the hope of this video is to kind of give some of that context with some of the major players in the e-note-taking space. And I'll actually be doing further iterations of this video as well, talking about some of the other players in the space that I've have experience with. So we'll expand this beyond this video. But today's video, I think, covers a lot of the heavy hitters in the industry. Now, just to talk a little bit about kind of my background with battery, when I started doing reviews, battery testing is something I really didn't want to touch. And there's a couple of reasons for that. The first reason is that it's a lot of work. I mean, it's a lot of work to sit and try to measure battery and, try different combinations and what have you. But also there's the question of what does it even mean to test the battery? Because how we use these devices differs dramatically. And indeed, as devices have come out, and I spend a lot of time on Reddit and the forums there because they're very helpful, and I try to help, but I also learn a lot from there as well. Sometimes you'll see people comment on the battery life of a new device, and you'll see some people say, oh, it's really good, and you'll see some people say that it's terrible. So how can you have these two very distinct opinions that are so divergent from each other? And I think that there's a couple of things, right? There's, people have different standards, so that's one factor. But I think how they use the devices significantly plays into that as well. And so it's a difficult question to answer. When someone says, what's the battery life of a particular device, it sounds like a very innocuous, very easy question to answer, but in practice it really isn't. And so what I've been doing is I've been kind of evolving in testing battery life of various devices. Is I've tried to kind of take that into account and to develop a system that might have more relevance. And I think I've done a lot of good work around that, but I probably could do some more, and I'm hoping to evolve that over time. So initially, as I mentioned, when I started doing devices, I didn't really want to get too deeply into this, and wondered if it was even useful to do so. So I really just focused on standby. It's really easy to measure, and I was hoping that it would be kind of a proxy for how devices would handle battery life overall. And I think there's some truth to that, and we'll see that in this video. But devices do have variation beyond that, and it really wasn't sufficient. And as I did more and more reviews, I realized that I just couldn't leave it at that. I had to go deeper. So with the Tab Mini C, for example, I evolved and I started testing all sorts of different combinations and put a tremendous amount of time and energy into that. And frankly, had no interest in replicating that again. It was just really draining to do that. And as it turns out, probably not even necessary. And this is one of the things I thought about and evolved with when the 3C came out, the book's Note Air 3C, that is I started to realize that I could start to isolate different aspects of a device and test, just the Wi-Fi or just the front lighting, or just a particular app or what have you. And then that could help make the battery testing process much more efficient and much easier to do, still taking a bit of time, but not taking the laborious amount of time that I had taken with the Mini C. And that's currently where my battery testing stands today. So with the Nomad, for example, that's the process I used. I isolated different variables of that device, measured them, sometimes measured them multiple times if I wasn't sure about the result, or over a long period of time just to make sure that that result was more valid than not, and then presented it. and basically said if you're turning on Wi-Fi, this is the drain you can expect, and you can add that to the system drain and add that to whatever activity that you're doing, and that gives you a sense of what battery life you may be experiencing with the device. So that's the idea. But again, in this video, it's less about that perspective and more about how do devices compare. And so just with that kind of history in mind and that context about my process, let's go ahead and start to look into that particular question. Now, I talk about in these slides I'm going to show with the different numbers for these devices that we're measuring today, is I have a footer that basically says that all values are approximations based on observations. And what I mean by that is that because I don't do a large number of tests for each scenario. So for example, you take the Nomad, you take Wi-Fi testing, I'm either going to do one long-term test where I might do it for a number of hours and then measure what the battery drain is during that time, or I might take a couple short tests. It just depends on the situation, but I'm not taking an exhaustive battery of tests. And so the result is that not every test will yield the exact same drain each time, but they will be close. So when I say the phrase approximations, what I mean is that in lieu of doing multiple tests, because I do a fewer number of tests, there is a little bit of variation there. But I think that the manner that I do it still captures the essence of the battery drain. I don't think it's a material difference. In other words, if I did, say, 10 Wi-Fi tests versus 1 or 3, I don't think the results would vary that much, but they might vary by a few percentage points. And indeed, after I show the numbers, I'll talk about a few of the numbers that have actually changed from previous videos, just to, if you notice the difference between the two, it's because we did additional observations on those, but they weren't significant changes, as you'll see later in the video. Okay, so we're going to start off by looking at 3 different categories of battery drain. And the first category we're going to look at is standby time with the screen off, standby time with the screen on, and then Wi-Fi drain. Now let me say a few things about what those things are. So standby time with the screen off is when the device is in a readiness mode, meaning that you either open the cover or you press the power button, and within just a couple seconds, it's ready to start being used, either for note-taking or whatever you have in mind. So any types of battery-saving switches or toggles are shut off on all the devices in all of these tests. So these reflect the pure drain of what's being measured. So, some devices go into kind of a sleep mode and some go into more of a deep sleep mode. All those things were shut off when I conducted these measurements. So as it relates to turning the screen off, the device never powers down. It just sits there waiting to be used, and that's what's being measured there. So one example of why this would be important is, let's say you're reading on a device and you put it aside and you don't get back to that device until a week later. Well, this gives you a sense of what that drain will be and whether the device will actually have power by the time you come back to it or not. So that's why I measure that. I also measure standby time with the screen on. And this is how I use my screens in many cases. So for example, I use the SuperNote A5X at work. I have it on my desk with the cover, with just the screen showing and ready to be written on in any second, just like a pad of paper. And so, I measure that because that's a common way of using the device, but there is battery drain related just to having it sit there. And so we measure that, and that's what I call standby time with the screen on. Nothing else is happening with the device. It's just sitting there ready to be written on, or whatever the case is with how you're going to use the device. The final category in this first slide that we're going to look at is Wi-Fi, and I think that's fairly self-explanatory. The one thing I will say about that, though, is that in my testing, I made sure that any apps were updated or any system updates took place first and then I tested Wi-Fi, meaning I'm really trying to test what it is just to have Wi-Fi on, but not necessarily actively downloading at the time. And so that's what that Wi-Fi means. It's having it active, but not necessarily downloading, but just kind of pinging the internet or whatever it is that Wi-Fi does. And that's the drain that I'm trying to estimate. So let's start with the results and see what that tells us about these various devices. Okay, here are the 7 devices that we're going to be reviewing in this video. Missing from this list is the Kobo Ellipsa 2E. That's something I'm actually currently reviewing as of this filming, and we'll release that in the coming weeks. And we'll include the battery information from that device then. But what we do have on this list is the Kindle Scribe, the books being well represented with the Note Air 3C, the Tab Mini C, and the Tab Ultra C, 3 devices released last year in 2023. The Remarkable 2, which is an older device, but still remains their flagship and latest release. The SuperNote A5X, which is probably SuperNote's most popular device. But then there's also the A6X2, or Nomad, which was just released about a month ago prior to this viewing. Next to all these devices, I have the battery capacity and the screen size, so it's interesting to see how that does or doesn't influence the battery drain as we go through the various categories. But having set the stage, let's go ahead and start looking at the numbers. We're going to start by standby time with the screen off. So again, how much battery drain is there when the device is on standby, but with the screen on a sleep mode. And our worst performer here is the Air 3C, which comes in at 0.12%. That's followed by the Nomad at 0.09%, the A5X at 0.08%, the Mini C at 0.05%, and then the Ultra C and Scribe both tie at 0.04%, meaning the Remarkable 2 is the best device on this list at 0.02%. And this is how I've always thought of the Remarkable 2 in terms of its battery efficiency, is based on this particular metric, which I thought would be a proxy for how it performs in other categories. And as we'll see, that turns out not to be true at all. But before we move off on this category, in all cases, these devices can last weeks and sometimes months in this particular mode. So all devices have a really good standby drain with the screen off, but certainly there is some variation. Now, if we move to the next category with the screen on, and again, this is where the device is basically ready to be used with maybe 1 or 2 seconds to be responsive, but otherwise it's pretty much ready to go. Well, in this case, the worst device was the Remarkable 2, a complete 180 degrees from the prior category with a 3.9% battery drain. And it gets worse than that. The gap between the Remarkable 2 and the other items on the list is pretty notable. The Mini C and the Nomad both come in at 0.5%, half a percent, and everybody else comes in at 0.4%. This is the one category where there's virtually no variation between the devices. They're all within the margin of error of each other, except for the Remarkable 2, which has this profoundly significant battery drain. And this is one of those data points where you do the measurement and you don't believe it. So I did this measurement 5 or 6 times, and it always came to this value or worse. So this is actually a legitimate representation of the Remarkable 2's battery drain, and the significance of this can't be overstated. See, the problem is, as we go through this review and we look at other categories, everything is going to be measured with the screen on. So the standby screen on drain is going to be inherent in a foundational aspect, if you will, of everything else that we're going to measure going forwards. So not only does Remarkable 2 lose this category, but this is going to make it very difficult for the Remarkable 2 to compete in subsequent categories. And indeed, with Wi-Fi, we see them coming in at 5.2%, easily the worst of the 7 devices. The Nomad comes next, almost cutting Remarkable 2's battery drain in half at 2.8%. That's followed by the 3C at 1.9%, the Ultra C at 1.6, the A5X at 1.4, the Mini C at 1.0, and the Scribe takes 2 categories in a row with a paltry 0.9% Wi-Fi drain. As a reminder, this is Wi-Fi just being on, not generally being active in downloading, although it's currently pinging the internet and what have you. But this is basically just what is the general drain you would experience with having the Wi-Fi option added. And it's notable. I mean, you're getting about 1 to, well, throwing out the remarkable, roughly 1 to 3% battery drain for most of the devices, which is a lot. That means, in a 10-hour period, it's 10 to 30% of drain. So leaving Wi-Fi on definitely does hurt the longevity and battery life of your device. So I think the takeaway here clearly is you want to turn off Wi-Fi unless it's in use, because that's going to allow your device to last longer between charges. All right, let's move on to the next category. All right, so the next screen we're going to look at is specific to front lighting. And the only thing I'm going to say about that is that we'll look at full front lighting and we'll look at half front lighting. And in my case, I did the tests based on the cold temperature of the light. There's also a warm temperature, and I did not review that. However, in the past, I've done a few measurements comparing cold lighting to warm lighting, and I found the drain to be identical with each. So cold lighting really is a proxy for whatever color temperature that you happen to be using on your particular device. I just chose cold. But the real thing isn't necessarily the cold or the warmth. The real thing that distinguishes the amount of battery drain is how bright is the light. And in my case, I measure full and half. So let's take a look at the results and see what they tell us. All right, so you'll notice the list is much smaller this time. Instead of 7 devices, we're reduced to 4, and that's because devices from Remarkable and Supernote don't feature front lighting. So that leaves us with the Scribe and the Books devices. Let's start with full cold front lighting, and we can see that the Note Air 3C comes in with almost 6% of drain per hour when the lighting is set to its highest intensity. That's followed by the Scribe at 5.3%, followed by the Mini C at 3.9%, and the Books Tab Ultra C at the lowest level at 3%. And I think this is a great example of where the battery and screen sizes are very much relevant. I don't think it's a coincidence the device with the largest battery has the lowest level of drain here per hour, and then the devices that are 10 inches and have the smaller batteries have the higher drain. That's pretty logical based on the sizes and the attributes of the devices. Now, half lighting is very different from front lighting. It doesn't just cut the amount of battery drain in half, it's much more significant than that. And we see the worst one, in fact, coming in at 1.1%, followed by the Scribe at 0.8%, the Ultra C at 0.7%, and finally the Mini C at 0.6%. And so much tighter battery drain between the 4 devices. And it just shows that if you just cut lighting to half, and it's good enough to use the screen, you're going to get massive battery savings for doing that. So I would say that's probably the biggest takeaway there. All right, let's go on to the next table. Okay, so now we're going into our final comparison grid. And this is basically looking at the 2 things that E-Ink does the best, that I think it does better than what it replaces, and that's reading and writing. We'll use the Kindle app to kind of measure reading, and then we'll just use whatever the native app is for each device for writing. It's pretty self-explanatory, but I will say one thing. It's really difficult to measure writing, especially in a way that's meaningful. And I'll talk in a little bit more detail about that. But the way that I measured continuous writing is I literally start the clock, the minute the battery counter changes, and then I start my stopwatch, and then I just start writing, and I don't stop. And I do this usually for roughly 10 to 20 minutes, just depends on whenever the battery counter goes down again, and that's when I stop the test. So the reason why I'm mentioning this is that it's the only way I know how to consistently measure the impact of writing. But in doing that in that manner, I'm creating kind of an artificial construct. Now, there might be certain cases where you'll find yourself continuously writing, and then you would experience whatever battery drain that I'm indicating. But I think most people don't write that intensively all the time. I would think of continuous writing, for example, as something more germane to a classroom setting, and particularly if you were a verbatim note taker, or any type of situation where you have to do just a lot of writing. But for most of us, just remember that you're probably not writing at that level, and so your actual battery drain will probably be significantly less. And indeed, in this example, as I go through some of the numbers, I'll share my personal experience that explains, partly how the numbers can differ, because I certainly don't do continuous writing in my day-to-day use of these devices. So just wanted to say that particular point. Let's go in and take a look at the numbers. Okay, this table is going to start with reading, and every device except for the Remarkable 2 has access to the Kindle app. So that's why we're using that particular app as a benchmark for all the devices. We'll start off. The Nomad has a 5.1% drain, and that's followed by the A5X at 2.2. Next up is the Mini and Ultra C at 1.1%, the 3C at 0.9%, and the Kindle, which is no surprise, being the most efficient at 0.5%. The curious thing is that the Supernote values seem pretty out of line with the other values on this list. And I don't necessarily know the reason why, but I do have a speculative answer for that. It strikes me that the version of the Kindle app on the Supernote devices is an older version of the app. I'm not exactly sure which version it is, but you can kind of tell, those that are familiar with the latest version on Android, you can see subtle differences in that app. And I wonder if, because it's an older version of the app, that some of the battery efficiencies that have been developed in later versions are missing from the Supernote version. Because there's no other particular reason why we would see such higher battery drain rates for this app, in my opinion. So that's my theory, and I'm going to stick to it for now. But outside of the Supernote devices, all the devices are fairly efficient. And again, you would hope and expect that the Kindle Scribe would finish the best. All right, let's close out with continuous note-taking. And again, this is just writing on edge for 10 to 20 minutes. And the Remarkable 2 was the worst. And remember, this is still carrying forward that system drain that we saw a couple tables ago. Nomad is next at 13.5%, Air 3C at 11.3%, the Ultra C at 9.2%, the A5X at 8.8%, the Scribe at 6.3%, and then the surprise, at least for me, was the Mini C at an even 6% battery drain per hour. Again, these numbers make a lot more sense just looking at them relatively. So you know that the Ultra C has less battery drain, for example, in writing than the Nomad has, but the percentages themselves are difficult to apply. So I'll go ahead and give my real-world example of that. As many viewers know, I use the Supernote A5X as my daily driver. And essentially, what I do on a routine basis is I come into work on a Monday, I power up my device, I leave it on standby mode the entire time throughout the week, whether it's with the screen on or off, and then I turn it off on Friday night. So if you account for all that battery drain, it equals about 21% of just being on standby. And almost like clockwork, when I go to charge my device at the end of the week, I have 70% battery left, so I'm burning 30% battery drain. That means that the writing must be the difference between 30 and the 21% for standby time, so it's 9%. So far from burning almost 9% per hour, I'm actually burning about 9% battery drain in a week. Now, to kind of help understand that a little bit, the way that I use my device is that I have it like a pad of paper, and it's on my desk. It sits beside my computer. Most of the work that I do in the office is on my PC. It's doing Outlook for email, it's Teams for meetings, it's Microsoft Word, and Excel and PowerPoint and so on. So I'm spending a vast majority of my time interacting with the computer, not writing on the notepad. I'm writing on the notepad, to take notes in meetings, or if I have some ideas I want to kind of draw out, or just to-do lists I want to create. That's what I'm using my device for. So most of the time I'm not writing. I'm just writing sporadically throughout the day. I'm writing every day, all throughout the day, but not continuously. So the 8.8% battery drain per hour has no relevance to how I actually use my device. And I think that'll be true for most people. So again, these percentage values are really about how these devices compare to each other, and less about what you would experience in a real world usage as you're writing on these devices. So I hope it helps. If anybody has any better ideas in terms of how to track this, I would definitely appreciate that feedback, but this is the best that I've come up with thus far. All right, let's go into final thoughts and conclusions. Okay, before we kind of get into a summary of what I think are the big takeaways here, I do want to point out, more eagle-eyed viewers might recognize that a few of the numbers have changed from previous videos, and I just wanted to call that out. The Books 3C, I did change the half front lighting. My original video had it at 1%. This video had it at 1.1%, so a very minor change. But a change nonetheless, and that's because I did additional testing. The Nomad on Wi-Fi, I had originally said 3%. That improved to 2.8%, again, due to additional testing. And the Kindle on the Nomad, I had originally placed at 5.5, and with additional testing, that actually dropped by 0.4% to 5.1. So that was a little more of a substantial drop. But this reinforces why these tests do produce approximations. They're roughly correct, but additional testing will show a little bit of variance in the results. But I felt like the additional testing I did here warranted corrections to the numbers, and that's what you saw here. None of the other numbers changed. Okay, so what are the big takeaways here? Well, for me, there's kind of three that stick out. First and foremost is how amazing the Kindle Scribe is at battery management. I mean, it was, if not the leader in a category, it was very close to being the leader of the category. And it had one of the smallest battery sizes of all the devices. So clear work being done to optimize the battery. And of course, the screen matters as well. The Kindle uses a Carta screen. And we compared it in some cases to devices that are using Kaleido 3 screens, which have a Carta base, but also have a layer on top of that. And so those devices are more energy intensive. But nevertheless, I think it's pretty clear that the Scribe is a well-calibrated device for battery drain, and it showed it in the results. That's the first thing that stood out for me. I think the other thing that stood out for me, kind of in an inverse, is how bad the battery drain was on the Remarkable 2. Again, had the very best standby time when the screen was off, and by a really large margin. But the other measurements weren't nearly as good, and I was really surprised at that. Now, it makes a little bit of sense. The battery itself is one of the smaller batteries. The device has been out for a while, so it's a little bit of an aged device and doesn't have necessarily all the updates that some of the other devices have that potentially could affect the battery performance, but I was still surprised at how poor it performed overall. And I think this does really kind of reinforce the idea that maybe it's time for a Remarkable 3 that can address some of those issues and be more competitive with a device like the Kindle Scribe. And I think the third thing that kind of sticks out for me, and this might be more controversial and you might not agree with it, so it's just my perspective, but I was kind of surprised how close devices were to each other. I mean, we only saw one case where they were right on top of each other, and that was the standby time with the screen on. So I'm not suggesting that they're all identical, and far from it, but they're all kind of, in broad speaking, in the ballpark of each other. Obviously, especially if you take away the extremes, the winners and losers of each category, they're much tighter than I would have expected. There is variation again there, but I just thought that there was less variation than I would have thought going in. So those were my kind of 3 big takeaways. But anyway, I hope you found this helpful, and I hope it gives you a sense of how battery life differs between devices, which is the hope of this video. And as I mentioned at the beginning of the video, I do hope to do more views on more devices on this particular analysis. So that will include MobiScribe, Kobo, and BigMe, and there'll be others, I'm sure, so you can look out for that. And I've got a whole year ahead of us, and I'm sure that over the year I'll probably think of different ways to measure battery, and we'll see that evolution continue. So who knows? So more to come. It'll be fine. Subscribe so you can be part of the journey with me, and I will see you then. Thank you very much for tuning in, and have a great day.